In this video, we'll be covering the basics of finding the inverse given an equation. So in this particular instance, we have f of x is equal to 2x plus 7. Now, if we're trying to find the inverse, what we want to do is find the function that does everything that this function does in the opposite order, in the opposite way. So what I'm going to do is I'm going to first start by taking this function and replacing that f of x with y. This allows me to view that this is, again, the output and this is the input. Now, to find the inverse, I really just want to swap the input and the output. So what I'm going to do is I'm going to swap x and y. This is the step to solving for what the inverse is. Once I've swapped x and y, now this right here, if I could get y equals, would provide me with what the actual inverse function is. So that's what I'm going to do. I'm going to go ahead and manipulate this function, attempting to solve for y, getting that new y by itself. Once I've done this, this right here is supposed to be the inverse function. Now keep in mind, this is currently an equation, and I already have a y equals up here. So this notation is improper to use. What I must write instead is, given we were given the function f of x, I should have f, again notationally, inverse of x equals x minus 7 over 2. This right here would be the inverse function that we're looking for. This right here will lose points because this is the appropriate notation and this is just an equation. Another example of finding the inverse is something that looks like this. Now in this function, we're going to be asked to find the inverse again, in which case, again, continue to swap x and y, and then get y by itself. So I'll add 1 to both sides, giving me x plus 1 is equal to 8y cubed. I'll divide by both sides by 8, getting y cubed by itself. And then to get y all by itself, I will have to cube root both sides, just like I would square root both sides, but this time because the power is a 3, I must cube root both sides. So that gives me y is equal to the cube root of x plus 1 all divided by 8. Now make note here how I've extended this radical all the way down below the 8. The importance of this is that everything on this side must be cube rooted and everything on this side must be cube rooted. Now, given that a cube root behaves like a power, I am allowed to distribute that power over division or multiplication. In doing so, I can simplify this thing a little bit further. So the cube root of x plus 1 cannot be simplified because there is no perfect cube of x plus 1. So that's going to stay as it is. However, the cube root of 8 is actually just 2. So you'll notice here that y equals the cube root of x plus 1 divided by 2. But, again, this is improper notation, and because we started with the original function f, I should end with f inverse of x equals the cube root of x plus 1 all divided by 2. And again, notice how this time the radical is not extending past that fraction bar, because up here I took the cube root of the whole side, I distributed that radical over division, and then I was allowed to simplify that. This is how we, again, attempt to find the inverse of an equation. Make note, however, that you must use the proper notation at the end of the problem to emphasize the fact that that is the inverse function.